Right. So guys, in the last session only, we have talked about the analytical epidemiology, right? Before that, we have talked about the descriptive epidemiology in detail, right? Okay, and we have touched upon the several important MCQs also regarding the descriptive epidemiology and the analytical epidemiology respectively, right? And today in this particular session, we are going to talk about that is the experimental epidemiology. So let's find out what we are going to actually study in this particular type of epidemiology or study, right? So in the experimental epidemiology, basically, if you remember my previous sessions that where I have talked about the types of the epidemiology, okay, where I was telling you that we are having the non-interventional study and the interventional study. I told you that in the non-interventional we are talking about the descriptive and the analytical study. So the descriptive and analytical we have already touched upon, we have already talked about them, but there I have told you that one is the interventional study, and there I told you that interventional study is basically your experimental study or the experimental epidemiology, right? And that experimental epidemiology which we have talked about over there, that was the interventional one. This particular study we are going to talk about in the today's session. So experimental epidemiology basically, guys, so first important point is that this is also known as the interventional study, right? Also known as, this is also known as interventional study. Okay, I'm writing AKA till now, you know this what I'm writing, AKA also known as. Okay, so interventional study, right? So also known as interventional study. First MCQ is done. Second point over here is that here we are going to talk about two kinds of trials. One is the randomized trial and one is the non-randomized trial. What is this particular randomization? We'll talk about that. So first of all, here we are writing on one side that is the non-randomized trial, non-randomized trial. Okay, on the another side we are just writing the randomized trial, randomized trials. Okay, very popularly it is also abbreviated as RCT, randomized control trial. Okay, nice. Now we just need to know the names which are actually coming in this category, that is the what are actually the trials which are coming under the category of non-randomized, what are the trials which are coming under the category of randomized control trials. Okay, we don't need to know the much details about these kind of trials as such, right? So coming to these non-randomized trial, okay, we are having these three important non-randomized control trial which are actually your, one is the uncontrolled trials where we do not have control upon them, uncontrolled trials. Okay, second one is your pre or post study, pre or post study design, right? I mean simply pre or post study means that, okay, for example, randomly I will just say that, okay, you are having the test now, okay, and some student will be there, they will be scoring good, some student will be there, they will be scoring poor, some student will be there, they will be scoring average. Okay, but I didn't teach you anything at that point of time. Okay, I collected your results, then I'm giving you the lesson on one topic, and then again I'm giving you the same test, for example. Now majority of the students actually, if I have taught you well, for an example, they will be scoring good marks, right? So that is a suitable example for pre or post study design. Okay, pre study before the study, post study after the study. Okay, so results might be different. Okay, so that is the pre or post study design example. Third one is the natural experiment. For example, let's say there was some kind of bomb explosion, right? Or there was, let's take an example of a very big tragedy, right? Bhopal gas tragedy, right? In the Bhopal. So Bhopal gas tragedy. So the patient, so the number of persons who were developing cancer before Bhopal gas tragedy, the number of patients who were developing cancer after the Bhopal gas tragedy, if you will compare, right? So that is the natural experiment example, right? So the study before any natural disaster, right? For example, Bhopal gas tragedy, before that and the after that, if you're comparing these two data, that is the example of natural experiment. Okay, just giving you the idea what I'm talking about, natural experiment, right? Okay, however, let's talk about the another side, that is the randomized control trial. Randomized control trial, in this case we are talking about clinical trial, right? Clinical trials. We are talking about the preventive trials, right? Preventive trials. We are also talking about the risk factor trials. Okay, you just need to know how the question will come. which of the following trial is not included in the randomized control trial? Okay, 4 options will be given. Okay, one option among those will be given of non-randomized. So you need to just identify that particular option and that will be the answer. Okay, so these kind of questions are actually coming frequently. That's why I'm just mentioning all these trials. So risk factor trials. Next one is the trial of etiological agent. Trial of etiological agents. Trial of etiological agents. Okay, not going into the detail of these. Then evaluation of particular any health related services. So evaluation of health services. Health services, right? For example, we are providing some health services to any kind of particular community, right? And we are analyzing the results for that. Okay, then for example, cessation experiments. Cessation experiment, right? That is also coming under this category only. Okay, so I've talked about 6 particular trials, okay, which can be considered under the category of randomized control trial. Okay, most probably they will be asking you the examples of randomized control trial. Okay, so at least you should remember these randomized control trials, okay, by heart. Now next point which I wanna talk about over here, that is what is the randomized control trial. So let's talk about this randomized control trial, RCT in short, right? RCT in short, that is a randomized control trial. In the randomized control trial, basically what is the design of this RCT? Okay, let's try to understand this with the help of this particular design. Okay, if you remember in the previous section also I took the help of design for case control study and the cohort study, right? Likewise, I'm taking this example of RCT with the help of design. Okay, first of all, what we will do, that we will review the study, right? We'll review the study. Okay, so ethical review of the study. Okay, ethical review of study. Okay, in PSM we are generally talking about ethics and all, right? So ethical review of the study. Then after that we will be actually finding out our eligible patients. We will be finding out our eligible patients. Okay, after that we will be taking the consent from our patients, informed consent. We will tell them, okay, we will write in one paper, okay, we will make them understand what we have actually written on that particular paper. We will inform the consent to the particular patients, right? And then we'll take their signatures and all, right? So informed consent, will take the informed consent. Without consent you can't run this randomized control trial. Very, very simple. Okay, be very clear with that. Informed consent is must. Then next point, then we'll do the main thing. That is the randomization. So now we will be doing the randomization. Okay, what do I mean randomization means? Okay, basically once I will be actually ready for doing some kind of test after taking the consent, okay, I will not be having some kind of bias in my mind, right? So if I'm having two kind of groups, okay, if I'm having two kind of groups, I'm not sending this kind of patient to this group, this kind of patient to this group. I will not be having this kind of bias. Okay, any kind of patient can go in any kind of group. That is basically the randomization. Okay, now then we will be looking for what? Then we'll be looking for two options. One is treatment. Okay, we'll be giving this particular treatment and then we'll be waiting for the outcome. What will be the outcome of the treatment of these kind of patients, right? On the other side, we are having control. Control means we are actually, look what we are doing. We are actually preparing we are actually doing the study, right? Ethical review of the study first of all. Then we are preparing our patient. I mean, we are actually choosing out our patient, eligible patient, because there will be some persons who will be actually saying, no, we are not ready for this particular study, right? So you need to actually, make them understand, okay, and what you need to make them understand that what you are gonna do in this particular study. Okay, so they should know about it, what kind of study we are gonna talk about. Then you will be taking your eligible patient, you will be taking their consent also, you will be giving the informed consent, right? So informed consent will be taken. Then you will be doing the randomization. Okay, so randomly you will be sending them into different groups, and then you will be giving them treatment. For example, right? For example, if we want to test for some kind of drug, okay, we need to do the randomization over there as well, right? For example, phases of the clinical trials, if you are running the clinical trials for the drugs, we need to do the randomization over there as well, right? We need to do the blinding also, right? I will talk about the blinding in further section, right? So that is basically the purpose of doing the randomization, right? Fine. So basically, why we are doing the randomization, we want to remove the bias from our mind. There should not be any kind of bias, right? In mind of an observer or in mind of any kind of patient, right? In both of these things, in the subject mind and in the observer mind, or neither in the analyzer mind, okay? In no one's mind there should be any kind of bias, right? Okay, then in these particular patient I will be giving some treatment, and I will be waiting for the results or out, right? I will compare this particular population with the control population. Control means we are comparing this particular data with some particular population where we have not run the test. Okay, so control and then outcome. Okay, and then we will be having our data that whether our actually study was useful or was having some particular positive effect or not, right? Or the negative effect, for an example, right? So this is basically the randomized control trial. Now, basically this randomized control trial, guys, basically this is the gold standard for clinical research. RCT is the gold standard. For clinical research. This is the MCQ gold standard for clinical research, right? And why is it so? Because we are going for randomization in this case, right? That's why. Okay, next point. For an example, I'm taking two groups. Why randomization? I have talked about that. Okay, just taking another example. I'm taking two groups. One is the group A, one is the group B, right? So, just before an year, we were having this, era for vaccination. Okay, we were having very popular vaccines, two popular vaccines. One was Covaxin and another one was the Covishield. Okay, so what we did is we made our two groups, group A, group B. Okay, we chose our patients, we took the informed consent. Okay, we did the randomization, right? For an example, we have not done the randomization. For example, we have not done the randomization. So what will happen now? Okay, let me explain. This was a group A, this was a group B. What happened is that in the group A, there was those persons, okay, we were giving the vaccines. Okay, which vaccine? I was giving the Covaxin, for example. We were giving the Covaxin. In the group B people, we were giving the placebo effect only. Okay, we were just injecting the normal saline in them. Okay, not giving the vaccine. Okay, you might have seen some reports also in the newspaper and the television that they were just giving the normal saline to the patient, not giving the real vaccine, but that is a different story, right? That is not this example. So what I'm saying is, guys, one is the group A, one is the group B. In the group A people, we are giving the particular vaccine, proper vaccine, either it is Covaxin or either it is Covishield. Okay, I'm taking the example of Covaxin, let's say. And in the other group, we are just giving the placebo effect, right? Now, after this particular thing, we waited for the results, we waited for the outcome. And let's say there are cases that there are some severe cases, there are some mild cases, there are some moderate cases of getting the COVID-19, right? So let's say I'm just putting the mild cases in the group A, right? I'm just putting those patients of the mild cases and just putting these cases in the group A, right? And the severe cases I'm just putting in the group B. So there would be bias in my mind that mild cases are going in the group A category because they took the Covaxin drug, vaccine. So basically, and in the placebo group, I'm just putting the severe cases, or I might do the vice versa. Okay, severe cases in the Covaxin group, mild cases in the placebo effect group, right? But here I know this, right? That I have put these patients, I have categorized these patients in these different groups. So there is no randomization. So there would be bias. So to remove this bias, there is the importance of the randomization, right? So if I will do randomization, some mild cases will go in this category, group A category, some mild cases will go in that category, some severe cases will come into that category, some severe cases will go into the different category. So this could be the example which we can consider under this example of randomized control trial or the randomization. Okay, I hope you got my idea. So randomization will be done while allocating the patient. While allocation, we are actually doing the randomization. So randomization is done while allocation. Randomization is done while allocation. Okay, important question guys, while allocation. Okay, understood, fine. So that's why I told you that what is the idea behind doing the randomization. Okay, so for checking any kind of drug efficacy for the phases of clinical trials, we are doing the randomization in these kind of trials. Okay, so once we are done with this particular randomization thing, right, now I'm moving on two important terms rather, that is the one is the intention to treat analysis and one is the per protocol analysis. So let's find out what are these as well. So first one is guys, intention to treat analysis, intention to treat analysis. Okay, come on guys, ITT analysis, intention to treat analysis, right? I'm having good intention to treat the patient, right? Okay, so intention to treat analysis, what does it say is that basically, you know, when we are doing the randomized control trial, okay, before understanding this, let's understand this which I'm telling you right now. For example, you were actually doing some randomized control trial. Okay, you took some patient, you took some eligible patient, you took their informed consent also. After that also some patient actually left away from your studies. Okay, you can't actually hold them back. Okay, please come in our studies. No, you will not do that, right? So actually it's their will. If they want to stay in this particular study, then they will stay. If they don't want to, then you can't actually, you know, hold them back that no, you can't go now. Okay, we are having this particular agreement and that agreement. You can't actually say like that. So it's their will. So let's say you chose your 100 patients. Okay, out of those 100 patients, 20 went away, 20 just, you know, ran away. Okay, we don't want this kind of particular study. Okay, so 20 just ran away. This 20 who are actually ran away, these people are called as attrition. These people are called as attrition, right? Okay, so the person, or you can call them as dropouts. So the person who have been dropouts actually, okay, so basically what you did is you did the randomization and after that you gave the treatment and you were actually waiting for the outcome. In that particular phase, they actually went out, they actually ran away, they were dropout from your cases. You were actually studying, you were doing your study on 100 patients, 20 ran away from your study, right? So now you're having only left with you, that is your 80 patients only, right? 80 persons only or 80 patients only, and 20 ran away. 20 ran away are called as the attrition people. Okay, they are called as the attrition people, right? Now you are having two options. You are having two options. Either you can wait for the outcome of those 80 patients. Either in the second option, you just don't care. Okay, whatever ran away, okay, just ran away. Okay, I will still actually, wait for the outcome of the 100 people. I will just calculate my study according to the 100 people only, because initially I took the 100 people. So I am having two ways. One is that, you know, taking the outcome of just 80 which are left with you, or taking the outcome of 100 people which I took initially. Okay, just giving you the example. So if you are including the dropout cases also, okay, listen to me very carefully. If you are including the dropout cases, the attrition cases also, okay, so you are having 100, okay, 20 ran away. If you are including those 20 also, okay, in your study, right? So what I'm trying to say is that if you are including the dropout from your randomized control trial, then this kind of study is called as the intention to treat analysis. Very simple guys. Okay, I took the 100 patient, I gave them informed consent, those were my eligible patients. Okay, I did the randomization, I gave them treatment. Okay, unfortunately 20 didn't like it, they just went away. Okay, still I don't care, I chose the 100 people, I will be continuing my study with the 100 people only. That is called as intention to treat analysis. I'm including those 20 dropout people also in my study. This is called as the intention to treat analysis, right? If in case, okay, this example is considered under randomization. In case if I'm not including those dropout people, I'm not interested in including the dropout people. Okay, I'm having bias in my mind. No, those people ran away. No, I'm not going to include them now. I will be just including my 80 people which I have left with. Okay, here you are having bias in your mind. So that is not the example of randomization anymore. This particular example will be considered under the per protocol analysis. Okay, so guys, writing here that intention to treat analysis, here I am writing that if you are including the dropout cases also, if you are including the dropout cases from your randomized control trial, okay, if they are included in your final analysis, then yes, you are actually talking about, this is termed as intention to treat analysis, okay, because you are including them, you were having intention to treat the people, intention to treat analysis. Second point which I told you, that this is the per protocol analysis, that is your PPA. I told you that now you are having bias in your mind. You are thinking that I took 100 people, how hell they left my study, right? So 20 people actually they ran away from my study, those were the dropouts. I'm not going to include these dropout people in my study now, okay? I'm getting biased now. This example will be considered in the case of per protocol analysis. Now in this case I'm having bias in my mind, okay? So this is no more an example of randomization. If the question will come, per protocol analysis, which of the following is not coming under the category of randomization, then your answer will be the per protocol analysis. Which of the following is coming under randomization, then among these two options, intention to treat analysis and the per protocol analysis, then in those case intention to treat analysis is the answer, because it is coming under the example of randomization. I hope I made my point clear. Right. So for the documentation purpose, I'm just writing that if I'm including those cases, if I'm not including the dropout cases, that will be the per protocol analysis, right? Okay. So including only those patients who completed my study, who completed the treatment, originally allocated to them, right? Okay, only those persons I am including. Very simple, guys. Okay, so not including the dropouts in this case. Okay, I have understood this, right? Okay, now moving on to the next particular important feature, right? Okay, right, I hope you guys are with me, guys. Okay, I'm trying to make it interesting. So now after the intention to treat analysis, after the per protocol analysis, I'm coming to the one more important design, that is the multifactorial study design. Multifactorial study design. So multifactorial study design. Okay, multifactorial study design, let's talk about them as well. In the multifactorial study design, it is also called as the crossover study design. So here, also known as aka crossover study design. MCQ, you have cracked one MCQ just now. Crossover study design. Next point is that it may or may not be randomized, but usually they are coming under the randomized control trial. So usually they are usually comes under the randomized control trial, but it may not be randomized as well. Okay, so may or may not be randomized, but usually they are coming under randomized control trial. Okay, fine. Now example, guys, very interesting. Group A is there, here is my group B as well. Okay, here I am having very important drug, okay, any kind of drug XYZ. Okay, so I am not having bias in my mind, I will not choose any kind of drug. Okay, I'm not choosing any kind of drug, just writing drug X. Okay, then you will say I am getting biased. I'm not having bias against any kind of drug, I'm not choosing any kind of drug, I'm just having drug X. If I will choose phenytoin or if I will choose any kind of drug, you will say I am having bias, right? Just kidding over here, just saying that I am having a drug X. Okay, so to group A population, there is a group A population, group B population. To group A population, I am giving any kind of drug, that is drug X. But in group B population, I am giving placebo only. I'm giving what? I'm giving placebo only. Now what I did after this, okay, what I did after this, I'm just, what I did, group A, drug X is given, group B, only placebo is given. They don't know about it. But okay, we were very smart, we just gave the placebo. Okay, fine. Now what happened is, we will just go for the drug washout period. Okay, we will wait and let the drug wash out from the body. Okay, so now drug washout will be there. So we'll wait for the drug washout period. Okay, we waited, and at some point of time, after some point of time, drug is getting washed away from the body. Okay, so in the group A people, we gave the drug X have been washed out from the body now. Okay, after waiting for some point of time. Okay, and then in the group B population, I gave the placebo, that has also been washed away now. Okay, for an example, next day again we did this particular experiment. Okay, again group A people are there, again group B people are there. Okay, so now as I said guys, I'm not having bias in my mind, right? So now in the group A people, I gave the placebo. In the group A people, I gave the placebo, and in the group B people, now in the group B people, I gave drug X. Okay, in the group B people, now I gave the drug X. Drug X. Okay, right? Fine. So group A people, first of all, I gave the drug X. Group B people, I gave the placebo. Okay, let it wash away from the body. Okay, let's say next day. Okay, in the group A people, we gave the placebo. In the group B people, drug X. So what you did? Cross over. What you did? What I did, guys, over here. What I did, guys, cross over. Okay, cross over. So this is called as the crossover kind of study. This is called as the crossover study design. Okay, this is called as the crossover study design, and that's how I told you how it is called as a crossover study design. Okay, understood guys? Very easy. So this is the multifactorial study design. Okay, now there are, in this case, there are some advantages of that. For example, it actually gives better analysis. It gives better analysis. It gives better analysis. Okay, and with that, there is no ethical problems. I told you, in the PSM, many people are talking about ethics. So in this case, we are not having any kind of ethical issue. Fine. Okay, now basically it is the best method to ensure, the comparability between the experimental and the control group, right? So it is the best method to ensure the comparability between the experimental and the control group. Experimental and control group. Okay, fine. Okay, understood this point. Now with that, I'm going to very important topic now, that is the evidence-based medicine, right? Very few important points I will talk about evidence-based medicine, guys. So evidence-based means I'm having some evidence now. Okay, and now I will be actually trying to evaluate the previous studies with whatever things I'm having right now, right? That is the evidence-based study. So let's start with the evidence-based medicine, right? So now let's start with the evidence-based medicine. So evidence-based medicine. Okay, so whatever I will be talking about, I will be having the evidence, okay, to prove that. So evidence-based medicine, okay, or EBM, evidence-based medicine, right? Okay, let's talk about this evidence-based medicine. Basically, it actually refers to the use of modern medicine, right? It refers to the use of modern medicine, okay, modern medicine findings, to actually help us making the decision to treat the individuals or to treat the particular patients, right? So we are having the patient right now. Okay, to treat these kind of patients, okay, it gives us important decision making capability, right, with the help of modern medicines or with the help of modern research, right? For an example, there was some hypothesis out there, okay, there was some hypothesis or there was some theory, right? Now I am having the modern medicine research, okay, or I would say the modern research modern research advantages, okay, with the help of those advantages I will be having important decision making capability to basically treat these kind of patients. That is called as evidence based medicine, right? So with the help of important evidences, okay, I will try to actually look for the important strategies by which I can use to treat my important patients, right? So that is the thing. So it is basically not the modern medicine, rather I should write modern research, right? So modern research findings to guide the decision making about the treatment of individuals or about the treatment of patients. Because after all, whatever we are doing for the treatment of the patient, we are doing for the betterment of the patients, right? Okay, we want to shorten the side effects, okay, we want to reduce the side effects, we want to reduce unnecessary burden from the patient's shoulder, right? And whatever we are doing, basically evidence-based medicine, it is for the betterment of, at least the idea behind the evidence-based medicine is for the betterment of the patients. Okay, fine. Now if you talk about who is the father of evidence-based medicine, right? So father of evidence-based medicine, once they have asked you this, father of evidence-based medicine, EBM, right? He is David Sackett. Okay, so he is David Sackett. Now next question, there are two important reviews, or I would say there are two important methods or criteria, okay, which we are studying in the evidence-based medicine, and these ideas are actually, one is your systematic review and another one is your meta-analysis. Which one is better, guys? Usually they ask you systematic review or meta-analysis. Which one is better? I will tell you. Systematic review or meta-analysis, right? This is your, not that meta which you are seeing as a pro version of Facebook. This is not that meta. Basically, this is the meta-analysis which you are reading in the evidence-based medicine, right? Okay, so systematic review, guys. In the systematic review, basically, we are having one particular topic, we are having one particular question, okay? Now, to read this topic, I will be actually locating my sources, right? Basically, I will be, trying to figure out that what are different possibilities, okay, I am having to read out this particular topic. Okay, so process of locating and synthesizing research for this particular topic, okay, that is called as a systematic review. Fine. So basically it is process of locating and synthesizing basically research on a particular question, right? So basically I am having this particular topic or particular question, okay, I will be locating my researches, I will be analyzing my researches to actually study this particular topic, that is called as a systematic review, right? So this is the process of locating and synthesizing, right, research on a particular topic, okay. So that is, okay, by the help of transparent methods and all, by help of organized methods and the transparent methods. Fine. So that is your which study, that is your systematic review. Okay, on the other hand, if you talk about the meta-analysis, basically here again, guys, we are having basically this topic or this particular question, this particular topic is there, right? Now I will be collecting my sources from different sources. Okay, I will be collecting my data from this source, this source, this source. Okay, I will be collecting my data from the different sources to read this particular topic. Okay, are you understanding? In the systematic review, I am just having one particular source of mine, okay, and that research, by the research I am studying this topic. But now I am just going one step ahead in the meta-analysis. In the systematic review, I told you I'm just locating, trying to, looking out for my research sources, and then I will study this topic. In the meta-analysis, I will be looking for different sources to collect the data to study this particular topic. So which one is better comparatively? Systematic review or meta-analysis? Meta-analysis is better, right? So in the meta-analysis, what I'm doing basically is that, right, in the meta-analysis, basically this is the statistical technique, right? This is the statistical technique. Okay, that's what your book says, the statistical technique for a combining quantitative results. What result I'm combining? The results from the different sources. Quantitative results from multiple studies to produce summary of empirical knowledge. Okay, in very simple words in our language, we will be actually collecting the data from the different sources, okay, and that will be collected, okay, that we will combine from the multiple studies to produce our summary of the empirical knowledge, okay, empirical knowledge to read this particular topic, okay, empirical knowledge on given topic. Okay, so which one is better according to you guys? Which one is better? Obviously you will say meta-analysis better, because here we are doing the study from the different sources. We are having much better sources available, right, to read this particular important topic, right? So okay, sometimes if they are asking you evidences pyramid in the research, basically the hierarchy I'm talking about, okay, which one is at the top? If I'm talking about as far as collecting evidences are concerned in the research topic, okay, in the research part, what is the best method if they are asking you? Okay, so what will be the answer? So here I'm just writing the hierarchy part over here. So basically hierarchy in hierarchy pyramid in research, I would say, or evidence pyramid in research. Hierarchy of evidence pyramid, I would say. Right, hierarchy of evidence pyramid in research, right? So here at the top, I will be keeping my meta-analysis, right? So till now, what we've studied in the epidemiology, guys, I'm going to include all of these things. So be very attentive. So first of all, we are having the meta-analysis. After that, what we are having? Systematic review. After that, we are having the systematic review. In any research, we are having the best method, that is your meta-analysis. Then we are having the systematic review. After that, we are having the randomized control trial, because we were doing the randomization. After that, we are having the cohort study. Right? Then we are having the case control study. Okay, I'm telling you who is having the highest top position in the research, and then I'm telling you that what comes next, like that, right? After that, we are having the case study or case series, and then at last animal study. Okay, so what they can ask you over here, they might ask you who is having the highest position, top position, who is having the lowest position. Okay, so this is the graph, not the graph, or I would say the position. So highest position is of obviously meta-analysis. Okay, highest position is of meta-analysis, so that could be your MCQ, right? And lowest position is of animal study. That might be your potential MCQ, so that's why I've covered that. So here I shall write the lowest one. Here I shall write the lowest one. Fine. So I hope you are clear with that. Now let's try to solve some of the MCQs, guys, at last. Okay, as I'm doing in every session. So here let's try to do these particular MCQs. Okay, fine. So guys, what is randomization? First question. Yes, come on. So what is randomization, guys? You should answer me this one. Right? Okay, waiting for your answer. Randomization. Is it brings bias in study group? No. It removes the bias rather. Right? So A can't be the answer. B option. It is the procedure by which participants are allocated into groups usually called study and the control group. Is it? Yes, it is the case. Because I told you what I told you over here is that one was the control group and another one was the treatment group or the study group, right? And we were doing the randomization. Yes, we were doing the randomization. Were we doing the allocation? Yes, we were doing the allocation. Yes, we were doing the allocation. Right? So what will be the answer in this particular case? That will be the B option, right? That would be the B option. Okay, that would be our MCQ. That will be our answer rather, right? Okay, guys. Okay, C option, ensure that investigator has full control. No, investigator, if he will be having full control, it is no more the option for randomization. So there it is no more the study of randomized control trial. It will become non-randomized, right? It is done usually before entering in the study. No, randomization is done after entering into the study. I told you, after entering into the study you are doing the randomization, not before, right? Before that you need to take the informed consent of the patient. You should be having the eligible patients also, right? So that is the thing. Next question. All are true about case control study except. All are true about case control study except. Okay, so if you have watched the previous session, guys, there I have talked about the analytical epidemiology, and there we have talked about the very important studies, that was cross-sectional study, case control, and the cohort study, and there we have talked about them in detail. So here is the question, case control study except. So attributable risk, attribute risk or attributable risk, that was example of cohort study, not the case control. That was example of cohort study, not the case control, right? So I told you relative risk or risk ratio, attributable risk, and the population attributable risk. These are the three options covered under the section of cohort study, not the case control, right? In the case control, I have talked about the cross product ratio, or also called as the odds ratio. Very nice. So this is the answer in this case, isn't it? So next question, guys. Next question, calculate the odds ratio from the following table. Very easy. Odds ratio is also called as the, guys, cross product ratio. First of all, it is also called as the, come on, it is also called as the cross product ratio, or it is also called as the odds ratio. Odds ratio formula I told you. Yes, odds ratio I told you, cross product AD by BC. Remember, AD by BC. Okay, BC. Yeah. So yeah, so this is A, guys, this is B, this is C, this is D. So A is your 33, A is your 33, B is your, okay, sorry, D is your 27 divided by, B is your 53, and C is your 2. Okay, C is your 2. So whenever you will be doing the mathematics, okay, what you will be got? You will be got something. Okay, let's say you will be getting X and you will be getting Y, but at last your answer will be 8.4. Okay, please calculate that. That is your task. Okay, I'm not having the calculator right now, and I'm not the mathematics person as well. So here answer will be the 8.4. Okay, I hope you guys are clear with that. Fine. Okay, so that is the case. Okay, I hope I'm right over here. 8.4 should be the answer in this particular case. Okay, whatever will be the calculation depends on that. Fine, guys. Okay, so that was about the experimental epidemiology. I hope you enjoyed the session, and I will be seeing you in the next one, where I will be talking about some particular types of bias. Okay, so see you there. Stay tuned. Thank you.